We're still going to do this proof as a flowchart proof, but this time we're not going to use an envelope with my statements and reasons to go through it. So let's take a look at our picture, our given, and what we want to prove before we get started. I'm given that D is the midpoint of CB and that side length AC and side AB are congruent to each other. Finally, I want to prove that angle CAD is congruent to angle BAD. So let's start with this first set of boxes in my flow proof with my first given. So D is the midpoint of CB, and I'll just write down as my statement, D is midpoint of CB, and the reason for that is it was given. Great. Now, what information do I get from that? If D is the midpoint of CB, I can then say, oh, well, CD and DB are equal to each other, and I'll draw that into my diagram. So I can just say that as my next piece of information. I can say that CD is congruent to DB. And the reason I can say that is, let's check our pink sheet over here for this. That's going to be hard. Let me move this so it's right on the... Oh boy, that's not showing up at all in the video. Let's see. That is the definition of a midpoint, if this shows up at all. A midpoint divides a line segment into two congruent segments. Well, that's exactly what we had here, is that I have D is my midpoint, and it's cutting into two congruent points, two congruent segments. So I can just say the reason I'm allowed to say that CD is congruent to DB is by the definition of a midpoint. Great. Next, I'm given just very directly that AC is congruent to AB. So I can say AC is congruent to AB, and that is given. Now this piece of information gets me one side. This piece of information gets me another side. I'm trying to prove that these two angles are equal though, and this seems to be moving me towards a proof of a triangle, right? The two triangles are congruent because I've got a side and then a side. Well, here I see I'm going to get my two triangles are congruent, and then I'm going to use the fact that corresponding parts of congruent triangles are congruent, and that's going to get me what I'm trying to prove. So let's get this these two equal triangles, these two congruent triangles. Well, the last piece of information that I see, it's not a given, but it is in the diagram, and that's that AD is equal to AD. And since the pink sheet's not really showing up so well, I'm not going to bother showing you that in the video, but I know that AD is congruent to AD, and that's because of my reflexive property. And I'll just write ref prop. And that gets me a third side. And so now I have that triangle ACD is congruent to triangle ABD by side, side, side. This is not a division sign, I'm just kind of cutting this box into a statement and a reason part. Now that I've got that these two triangles are congruent, if these two triangles are congruent, that means every single part of them is also congruent with the corresponding part of the other. So AC corresponds with AB, and those two sides are congruent. Angle C corresponds with angle B, so now that I know the two triangles are congruent, I know that these two angles are congruent. And finally, similarly, angle CAD, this angle over here, must be equal to or congruent to angle BAD, because those are the two other corresponding parts of my two triangles. So I can just say what I wanted to prove, that angle CAD is congruent to angle BAD. And the reason that is, and this is our full, big sentence here, the corresponding parts of congruent triangles, corresponding parts of congruent triangles are congruent. Oof. The corresponding parts of two congruent triangles are congruent. That's what we just said. These two parts correspond with each other, and because these two triangles are congruent, that means these two parts are congruent. And this is the reason I'm allowed to say that over there. And that just about finishes our proof.